My name is Kit. I work for Yahoo, and I'm going to talk about the WebAssembly plugin for ATS that I have tried to open. I actually open sourced it earlier this year. So before that, we're just doing a really quick recap of some way of extending ATS. So we can always do C and C++ plugin. It allows you to actually do some extension of the HTTP and TLS handlings for connections with clients and origins, etc. But there's a steep learning curve. A lot of people take a lot of time to actually learn how to write C and C++ plugin, and so it's not quite productive to train a lot of people to do that. You can obviously make behavioral changes using header rewrite and then a transaction box, but there's a limit to that. So these are like domain-specific language. They are mostly not Turing complete, meaning you cannot write loops and things like that. And there's no unit testing framework as well too, so you can't write tests against them. For that too, and they don't actually cover all the C and C++ capabilities, C and C++ plugin capabilities. So I've been trying a lot to popularize doing the extending of the ATS using the Lua plugin. It's a scripting language, much easier to learn. In our experience, we can train a lot more engineers to actually learn the scripting language really fast and make them productive very quickly. And so the Lua plugin covers most of the capabilities of the C and C++ plugins. And the LuaJIT FFI, the foreign function interface, allows integration with other share libraries as well. But we started to see some problems with the Lua plugin. The major one is that the popularity of the languages is kind of going down. It has been quite popular a few years back with some other movements that I'm not going to touch too much into. But nowadays, fewer people learning this language. And when I kind of survey the open source communities, I'm seeing less and less newer libraries that comes up that provide supports for bindings with Lua for that. So we're looking into a different approach. This is where we comes into the Proxy-Wasm. I think a couple of years back, I think John Privak actually come up and give a talk about a prototype that he built. So my work is on top of what he was doing. And so the Proxy-Wasm is actually a project, open source project. So its main goal is to try to provide WebAssembly support for proxies. And so there's many paths to the project. You can go and check it out. So it has a spec, and then it has a libraries in which you can actually use the libraries to help your proxy software to provide the support for the proxy for the WebAssemblies as well. And the library takes care of the integrations with various different runtimes. So there's multiple different runtimes of WebAssembly, such as a very popular one like the V8, VASTime, and VAST Edge. There's something less popular like WaveM and the MAWAM for that. So each of the runtime has a slightly different characteristic that I'll kind of cover that a little bit as well too. And the project also provides a lot of SDK. So the SDK is to help you to write and come up with a WebAssembly modules or programs for that, following the spec. So the projects provide the C++ and the Rust SDK, so you can actually write C++ or Rust program and then compile them into WebAssembly modules. And those should be actually working with the proxy that support this specifications. There are third-party SDK. A lot of people are interested in this, and they provided SDK in different languages, such as AssemblyScript, TinyGo, SIG, etc. There's a few proxy software that is actually implementing this spec already. There's the most prominent example is Envoy, and I've seen one in Nginx already, and it's partially done. And there's another thing called the Morsan, I think is coming up from some Asian companies that they develop overseas for that. So I built a plugin for that, and so this is plugin architecture for that. So ATS is obviously getting the request from the client and sending it to the origins, and the plugin intercept the request and then try to do something with it. For that, I don't mean an intercept plugin. I mean, it's just hooking into the various hook points and then provide handlers for that. So what the plugin does is it fire up the runtime, either one of those I just mentioned, but in our case, we only support WaveM for now. So the runtime will actually load the modules, which is the WebAssembly program. And so whenever we have some handling for the requests coming in, so the plugin will pass that to a specific functions that is defined in the modules. And then so the modules will run that functions. And so when the function needs some capabilities from the ATS, such as, hey, I want a header, or I want the URL path, or I want the request method, then it call functions back. And so that functions will go back to the plugin and say, the plugin knows how to actually interact with ATS to get those informations. It gets those and pass it back to the modules so that the modules can finish what he actually wants to do. And so this is a little bit about the code architecture if you're interested in looking into what I did for that. So as we said, hey, oh, I don't know why it goes back. Yeah, so we are talking about the code structure, and so the library provides some base classes of WAS space and the context space. So we provided the extended classes of them. So what the WAS space extension is going to do is that is initiating the runtime, load the modules and the configuration, while the context is actually the extension of the context space is actually trying to provide the implementations for the handler functions and the API functions. So the context is actually important in this case of how we actually handle the request. So when the ATS startup, we will create a root context. And so the root context will contain all the basic implementations of everything. And every time we actually get a request, we will create a context from the root context. So each of the requests will have their own separate context to be executed in. So they're separate in that sense for that. So let's try to do a demo.
Quick question. That concept of context, it sounds very, very similar to how the Lua thing works, right?
Yes. Yeah. So basically, it's the same. If you're playing with a lot of things such as a V8, that's the same idea about isolate. And in the Lua world, it's like pretty much the same as the Lua VM. If you have been dwelling into those ideas for that. So it's actually very much the same.
And the cost of cloning that WASM context is
really small. It should be very small, yes. Yeah.
So going back, your WASM module, that is a piece of code that you're pulling from someplace else, and then you're
yes. So you can use the SDK to write the program. And no, actually, you write the program and you use the SDK to compile the program into the WASM modules for that. So here we are going to actually do some demo here for that. So the first demo I have is a C++ program. I hope this is large enough. Right, when you write a C++ program, is it large enough? All right, cool. When you write a C++ program, right, you can actually, I'll skip a little bit for that, unless you're really interested in it, but you provide some interface for like when you are getting the request headers. So what you want to do when you get the request header is you want to be, for example, print out some IDs. You can print out the request header. You can print out the number of headers you have. You can get the current timestamp. You can also add a header into the request for that. So what I have is I've already set up an ATS that is have this plugin running. And so let me try to do this. So in my plugin.config, I'm actually having the WASM plugin, and then I'm passing it a YAML file to it. So what's inside the YAML file is actually that I'm actually providing the WASM modules that I've compiled from this program. And I've provided some other informations such as like the VM ID or the root ID. These are actually important when you try to load multiple WebAssembly programs. Okay, for now, we only support running one WebAssembly program at a time. So I do have plan to run more than one later on. But once we have this, it should be running. My routing should be very simple. Yeah, I'm actually passing on a test.com request and send it over to http://bin.org. So I turn on debug already. So my debug is on the right-hand side of the screen. So you should be able to see that. Right, so you can see that we are printing the headers, as I said, and then we're printing a number of headers, we're printing the timestamps, etc. There's a lot of debug information that I was printing in that particular plugin, and you can see that we are adding a new header into it. So because in the HTTP bin, if you do a / header, it just prints out all the headers that is come from the incoming request. So I can add a header, and it's showing up that I'm adding a header for that. So that's the C++ plugin. So the second example I want to show is Rust plugin. So you can actually run a Rust program. So in my Rust program, what I can do is there's a bunch of things, but I'm printing all the headers out. So in this case, I'm getting all the request headers. I'm printing all of them out. And then I'm getting a specific headers like the user agent, and I'm printing that out again. And so the next thing is a little bit cooler, in which I take a token request header. And then if the token is actually a prime, so as you can see, in the Rust, I can load a separate library to determine if a number is a prime or not. And if it is prime, I'm just letting it go. But if the token is missing, or if it's not a prime number, then I'm going to reject the request and give a full free instead. So I can now try to change my plugin to use that program. Sorry. So I restarted, and then I can try to send the same request. And this time it will actually get rejected. As you can see, I get a full free, right? Because I didn't pass on a token header. But if I'm putting a token in, which is a prime number, then it will get passed over. And you can see all the message getting print. I'm printing all the headers on this size. And then I'm also printing the user agent again, as you can see. So that's, sorry. Yeah, so that's the summary of the demo. That is that I'm demoing the C++ example, showing that I can have handler functions when I have a request. Similarly, you can do it with a lot of different other handler functions that the ATS has, such as for the response as well. We demonstrate logging, getting and setting the headers, and getting a timestamp of that. There's many more functionalities we can support. And I've also demonstrated using a different programming language that I can use to actually program for the ATS to make a plugin out of it. So let's do a real world example. This is actually just happened last week. We have somebody from my team actually going to the AppSec, which happens, I think, 2 weeks ago. And during the AppSec, they actually have a new library called the Proxy-Wasm. And it is an open source web application firewall library. So it is pretty much the same as the mod security, and it's accept the same language as the rule set for the mod security, and it's written in Go. So it's a Go library. You can write the server in Go, and then you can invoke this library, and then it will actually consume some more security rule sets and do some things for you. And so one fun thing the project actually did is they come up with a Proxy-Wasm program for this library. And they were initially supposed to actually have it to work with Envoy, and it's working fine with Envoy as well too. So why is screen back? Right. So they compile. This is a Go library. So they if you're familiar with the Go ecosystem, then the tiny Go is actually a pretty cool compiler in which is used to actually compile your Go program for various other architecture like a microcontroller and things like that. One of the targets the tiny Go can do is to compile your Go program into a WebAssembly modules for that. So they did that, and the project actually, if you go check it out, and it is all I have done to try to make it work on ATS is I go here and download the Docker images. That actually the Docker image is nothing other than containing the WebAssembly modules. And so once I have that, I can make it work with ATS with no change to my plugin at all. So we can examine what I did in the YAML a little bit. So I have in my YAML, I said I want to use the plugin, the WebAssembly modules that I've downloaded, and I supply a set of more security rules for that. So what I did is try to turn on the debug log, and then I'm going to say if my user agent is Perl, then I'm going to deny my request for that. So I just did the changes, I think. And so let me restart Jazz. All right, it takes a little bit while for that. Yeah, so this might be a good time. So why it takes a little bit while is that this is a different characteristic of different runtime. Some runtimes are doing a lot of things behind the scene, like pre-compiling things into assembly language and stuff like that. And some compiler is basically some runtime is just an interpreter of the binary codes in the WebAssembly module. So they have different type of load times for that. Right. So it is finished loading. As we turn on the log, then we are seeing that okay, we are interpreting the different rules that I've defined in the configurations for that. So now I can try to run again. Same request, it should go fine. But if I'm trying to use user agent for Perl, it will be problematic. Oops.
It's dash can play. Someone uses code too much.
All right. So it's rejected. Yeah. So that's the magics. That's what we want to actually show here, is that if you have built a WebAssembly modules following the SDK, you can have it run on multiple different proxy servers. And so now, like all these different people who build specific functionality for proxy, like security modules or maybe web application firewall, they don't have to choose to build for just ATS or just for Envoy, they can build a WebAssembly modules, and so different proxy who support that spec can actually have it work right away. All right, so it's open source, but it's far from perfect. I don't fully implement everything. So the first thing that I didn't implement is I only support WaveM as a runtime. The library allows us to easily support various other runtime. I just have to really sit down and support that. As I said, different runtime have different characteristics. Some runtime have a faster load time. Some runtime has a slower load time for that. Some runtime actually have restrictions on memory usage, etc. for that. So there's various different characteristics of different runtimes here. I haven't fully support all the functionalities in the spec, so I didn't have anything to actually retrieve and set the request and the response body. I can't do async request. I can only load one modules right now, but the specs should allow us to load more than one modules. So you can define several modules in the YAML, and then they can run at the same times for the ATS for that. Obviously, more production testing and performance testing is needed. There's some limitations too, because Envoy and ATS is two different things, and there are some things that Envoy support that ATS does not, and vice versa. So some of the things in the spec, we know we cannot support unless there's some changes in the ATS. So for example, the spec asks for us to be able to set and get trailer headers, and then they also allows the program to actually get and set HTTP2 metadata frame. And there's also some gRPC lifecycle support, lifecycle function supports as well too. So we can't do that yet in our plugin, and we know that would be the limitations of some of this stuff. So why do we want to do all this, right? So there's some use case to think about when we are doing this. So we have been writing a lot of plugins, and some of our plugins is really complex, and they are critical to the business. And if there's bugs, they can actually cause ATS to crash. And so that's no good to business for that. So, but with the implementations as WebAssembly modules, what we are thinking is that this kind of bugs will not actually cause ATS to crash, but rather it will just cause the runtime to complain. And so it will just be having problem for that particular request instead of crashing the ATS for that. Another thing is, obviously, this allows us to actually share plugins with other proxy server like Envoy, and hopefully in the futures, and Nginx and some other things as well too. And it allows us to program in other much more popular languages, such as Rust and Go, etc. for that. So that's all I have. Questions? Did I go too fast?
Yeah, question.
So,
yeah, the WAF thing, that seems really cool.
Yeah.
When you load more than one rule, what's kind of the performance overhead? Or what's in general, is there, I assume there's some cost for going through the WASM interface?
Yeah, I have tried this out in the productions by adding like some dummy headers and then run it inside Yahoo for like the percentage of traffic. And so it's pretty good. So I think it's doing okay. Yeah, but I don't claim to have done like rigorous testing other than but rather than like doing that much rigorous testing. Yes.
Who will be responsible for garbage collection, memory management? Is it ATS?
WebAssembly doesn't support garbage collection at this point. Yeah. So the program doesn't do that. No, the program you come up with using the SDK, which is the WebAssembly modules, doesn't have the capability of doing garbage collection at this point. This is one of the things that the WebAssembly community tries to introduce into that. So hopefully by the time they support it and various runtime support it, then it will be exposed to the to us kind of for free. Yeah. Cool. Yes.
Yes, I know you said that you haven't done performance benchmarking in production, but just in a very small scale environment, even on your development environment, do you have any idea of the performance difference between, let's say, a plugin written in native C++ versus Lua-based plugin versus a Wasm?
I don't, but I'm pretty optimistic to the things because there's a lot of support behind the scene for the web assembly communities, and there's various different runtimes or various different reasons or offering different characteristics. So I'm not too afraid of being supported by various other communities in that sense. So yeah, I don't have anything concrete, but I'm optimistic. Yes.
Yeah, I understand. But some kind of testing should be very easy to do.
Yeah, we can. Yes. So as I said, I did try like doing some addition of dummy headers, and I don't see any performance degradations in my service for that. Yeah. Cool. Yeah, sure. Yeah.
So in your examples of like to load a module in place, we only are loading one at a time. It requires a process restart.
Yeah.
Is that intrinsic to the model if you're adding a new web asset program? Or is it just
I actually have programmed it so that you can make changes to the YAML without restarting ATS, just doing an ATS reload, then you can reload the WebAssembly module. So I have added that functionality. So yes.
Yeah. One more feature that I was very curious about is the security or the isolation aspect that you mentioned, that the bugs causing ATS to crash. That's like the biggest headache that we have at LinkedIn.
Everyone.
So I was curious as to do the Lua-based plugins also provide similar security? And the second question is, with the Wasm plugins providing that security, is there any still drawback? Let's say I have a plugin where the runtime is complaining continuously for every single request. Does that affect the performance in any way?
So from the security standpoint, from my experience doing a lot of Lua programming and things like that, I think we do make like some bugs in the Lua plugin over the years. But then aside from that, when you run the program, write the program in Lua and run it with the Lua plugin, we think that it's much less chance for you to screw up and make mistakes and not releasing certain resources that you're not supposed to, and for that. So that's actually doing pretty good. So we expect to have similar kind of protections with the WebAssembly modules as well. Yeah. So I think the security aspect of it is really good with this kind of approach with the Lua and WebAssembly modules. It's like, and it really improves the productivity of the engineers. I was having really a big hard time to train like maybe half a dozen of engineers to write C and C++ plugin, but I can have like over 100 engineers that can actually write the Lua script, and they make changes on a daily basis with the Yahoo websites for that. Yeah.
Thanks.
Cool.
One more question.
Yeah.
One of your later slides said something about not having L4 hooks. Is that TLS hooks?
Yeah, that's the TLS hooks. So there's some TLS hooks functions defined in the spec. I haven't actually written support for that.
So they're in the spec.
They're in the spec. There's some part of that is in the spec, and I in my presentation I should have links to the spec that you can try to peruse that a little bit as well too. So that's pretty easy to get a hang of if you are like familiar with writing plugin for ATS. Yeah. Cool. Yes.
Do you know the second to last slide that you had?
Second to last.
There was a slide that mentioned HB2 meta data frames or something like this.
Yes. Yeah. So
what is that referring to? Window update frames? Or?
Yeah. So in the, I'm not too sure, but in the HTTP2, there's a metadata frame, and what the spec is to say is that you can actually retrieve and set data into those frames. So let me try to see if I can find that very quickly as a demonstration of going through the spec. I should have made it linkable.
You want to spec that you chose, or the last one that you chose? What other companies are using it?
Runtime, you mean?
Yeah, the runtime. Sorry.
Like Envoy.
I have a question for you, kids.
Yeah.
So when I looked at this and I tried to compile it,
Say it again. Sorry.
when I looked at this and tried to compile it, it has some pretty strict requirements and dependencies on LLVM versions,
Yes.
and they're pretty old. And a
Yes.
concern I would have is that the development of these, the Proxy-Wasm and whatnot, is not keeping up with where the world is going. What's your thought on that?
My thought is that is isolated from the Proxy-Wasm. So the Proxy-Wasm is a spec. It's a fulfillment of the spec for that, and then it actually relies on the runtimes to actually do the things. So the reason why we have an older version of the LLVM runtime is that one of the runtime that I choose to use, which is WaveM, requires the LLVM's 9, I think, and that is really old.
It can go up to 12.
Yeah. So I think it really depends on which runtime I use. So if I'm using different runtimes like the WAS Edge or WAS Time or even V8, their requirements will be different. And I really think it really depends on which runtime you choose. And some of the runtimes can have some of the later versions of the LLVM.
You're saying the Proxy-Wasm can use a different runtime?
Yes, the Proxy-Wasm allows you to use several different type of runtimes. I think.
So why did you choose the one that doesn't seem to be well supported?
That is because it is easier. It's the easiest for me to understand. Yes. Yeah. So
it doesn't instill confidence, right? I mean, you're looking at from an open source perspective.
Yeah.
Someone that's stuck so far behind.
Yeah.
On staying up, it doesn't.
Yeah. That's
a well functioning.
That's so true. My next one I want to support is the WAS Edge or the WAS Time. So which are the two of the most popular projects. So I'm trying of getting my feet wet to actually understand a little bit more in this world. So that's why I picked the easiest first. But you're right. So the next one we should pick the more popular one and get a little bit more popularized in this area. Yes, that's very true. Yes. Any other? Oh yeah, there's questions from other. All right. Any other things? Oh, I'll be here if you're interested. Just come talk to me if you're interested in the WebAssembly modules with us. All right. Thank you.